All right, welcome calculus students. If you recall, in the previous section we learned some things about finding derivatives that don't require the limit definition of the derivative. The limit definition being the limit as h approaches 0 of f of x plus h minus f of x over h. And some of the things we learned were formulas for deriving. And those formulas: derivative of a constant is 0. The derivative of x is 1. A biggie right here, the derivative of x to the n is n x to the n minus 1, which is known as the power rule. We have the constant multiple rule, which is the constant times the derivative of the function. We also had the sum rule, saying that the derivative of a sum is equal to the sum of the derivatives. Similar with the difference, the derivative of a difference, the difference in the derivatives. And a personal favorite, the derivative of e to the x is e to the x. You'll notice that some of these resemble the limit laws. And so it would be interesting to see if we could extend them to products and quotients. And that is exactly what we are going to do today. So the product and quotient rules. The product rule talks about the derivative of a product, two functions, f and g, being multiplied, and we want to know what the derivative of that is. The quotient rule, as the name says, is the derivative of a quotient. So here we have f divided by g, and we would like to know what the derivative of that is. I would like to point out first and foremost that it's not as easy as some of the other laws. What the product and quotient rules are not is that the derivative of a product is not the product of the derivative. It's not that easy, so we can't do that. The derivative of a quotient, you see here on the bottom, is not the quotient of the derivatives. We also cannot do that, so don't make that mistake. We're going to talk about some rules for how to do those, and then do an example or two, and we'll move on from there. So the first thing we're going to talk about is the product rule. So the product rule. We're going to let f and g be differentiable functions. And we need them to be differentiable functions so that we can take their derivative. So the product rule, the derivative with respect to x of f of x times g of x is, here's the way it works. We take the f of x, the first function in this product, and we multiply that by the derivative with respect to x of g of x, the second function, which you see right here, and we add that to g of x times the derivative with respect to x of f of x. So it requires us to take the derivative of both, but to incorporate them into a sum where we've got the product of f and the derivative of g, and the product of g with the derivative of f. So that can be complicated. The Leibniz notation doesn't make it any easier. So if we look at it in terms of prime notation, we get sort of the same thing. Here we have f times g prime, so that's the derivative of f at x, is f of x times g prime of x, the derivative of g, and g of x times f prime of x. Again, can be rather daunting. Some ways that you can think about it to help you remember. We often refer to the f, or the first function, and the other part of the product as the second function. So we've got the first and the second. And so the derivative is the first function times the derivative of the second function plus the second function times the derivative of the first function. And I actually say those words, first times the derivative of the second plus second times the derivative of the first, when I'm doing the derivative of a product. We also can simplify things by leaving x out of our equation and simply talking about f times g prime as being our product. And that is f g prime plus g f prime, which says the same thing. It's the first times the derivative of the second plus the second times the derivative of the first. And one last way, which some people find helpful, is to remember this, and that's 1d2 plus 2d1, which simply means that we are looking at the first function times the derivative of the second function plus the second function times the derivative of the first. So it's first derivative of the second plus second derivative of the first, as we said earlier, but they remember it as 1d2 plus 2d1. I don't know what's going to be the best way for you to remember it, but it is going to be something that you're going to have to memorize. It's a tough thing to figure out in the middle of a test if you don't already know it. So let's do an example. So here we have f of x equals e to the x times the square root of x. So that's a product, and e to the x is our first function, so that would be like the f up in here in our little formula. The square root of x is the second function, so that's like the g in that little formula, and we do have a product. So I'm going to write out what the product rule says to do, and that is we take the first function, which we said was e to the x, so e to the x times the second function. We take the derivative, the square root of x, and then we add that to, now we go to the second function, which we called e to the x, or I'm sorry, square root of x, so it's square root of x times the derivative with respect to x of e to the x. Now the part of this equation that I've written out now, which has the derivatives, you're probably not going to write that out that way. I did it just to illustrate the definition in action. In general, you're probably just going to take that derivative as you go. So you would probably write the first times the derivative of the second. Well, the derivative of square root of x, we know from the previous section, is 2 root x plus second function, square root of x times the derivative of the first function, and nicely, the derivative of e to the x is just e to the x. So that is the derivative. It's left now to us to do some simplifying, and we should probably try and simplify them as much as possible. I notice right now that there's an e to the x, which is a common factor in each of the terms, so I am going to factor that out. That will leave in the first term 1 over 2 root x plus, and in the second term it's going to leave us with just the square root of x. And so I factored that out, and inside the parentheses it's common practice to want those to be just one fraction instead of a fraction times another function or plus another function. So I'm going to leave the e to the x alone. On the inside of the fraction, we are going to have a common denominator, which is 2 root x. The fraction part, the 1 over 2 root x, has the common denominator. The square root of x does not. So I don't need to multiply the numerator of this fraction by anything. I can leave it as 1. The second part does need to be multiplied by 2 root x. So I'm going to multiply square root of x by 2 root x, which is going to give me 2x. And now I've combined those. There's really no other simplification. So this is what we're going to call the derivative of e to the x times square root of x using the product rule. All right, so moving forward, we have the quotient rule. The quotient rule is a little more complicated, if that last one wasn't complicated enough, but it's something we can handle nonetheless. We're going to allow f and g still to be differentiable functions. I'm not going to rewrite that. I'm just going to write the quotient rule, which is the derivative of f of x divided by g of x. And the way this works is we start with the function in the denominator, g of x. We multiply that by the derivative with respect to x of the function in the numerator. Then we subtract this time. That's important. That's a common mistake, is to forget the subtraction. And we're going to multiply that by f of x, which is the function in the numerator, times the derivative with respect to x of the function in the denominator. And now I'm going to make a very big fraction bar. because what goes in the denominator of this is the function on the bottom, g of x, but squared. So that is the quotient rule. Again, the Leibniz notation makes it expand very quickly. It looks very complicated. So we will look at the prime notation version, which is simply to say that we've got a quotient, and we want the derivative. So we take the function on the bottom, g of x, the derivative, now we're using the prime, so it's f prime of x, minus the function in the numerator times the derivative of the function in the denominator, all over the function in the denominator squared. Still a little bit intimidating. Another way to think about it is just to refer to the function f, which is in the numerator, as the function on top, and then g as the function on the bottom. And then sort of this mnemonic or repetitive sequence of words is kind of where some people go to remember. So we take the bottom function times the derivative of the top, so it's bottom derivative of the top minus top times derivative of the bottom, and that is all over the bottom squared. So it's bottom derivative of the top minus top derivative of the bottom over the bottom squared. We also can, again, with the prime notation, if we don't put the x's in there, it still means the same thing. It might be a little bit easier to look at. It's gf prime minus fg prime over g squared. Again, I think a combination of remembering these from a variety of ways is probably the way to go. Also, as a mnemonic, we have this, and this represents bottom derivative of the top minus top derivative of the bottom over bottom squared. So it's b dt minus t db over b squared. Those letters all rhyme, so that might actually be even more confusing, but some people like that to use to remember. So let's do an example. And here is two functions, x minus x squared being divided by e to the x. So let's follow our quotient rule. F prime of x is, so we start, as it says up here, bottom times the derivative of the top. So we always start with the bottom times the derivative of the top. So the derivative of the top, and I'm just going to take the derivative without writing it all out this time. So we're doing the derivative of x minus x squared, which is 1 minus 2x. And that's using the difference rule, it's using the power rule, and our knowledge about the derivative of x. So from that, we're going to subtract at the top function, x minus x squared. And that's going to be multiplied by e to the x. And all of that's going to be over the denominator, which is e to the x. And that is going to be squared. Again, simplification sometimes is the hardest part of this. First thing I notice is that the two terms in the numerator have e to the x as a factor, and the denominator contains e to the x as a factor twice. So I can cancel from each of those if I divide out one of those e to the x's, and that leaves me that. And so if I algebraically then rewrite this, the numerator is 1 minus 2x minus x plus x squared. Don't forget to distribute, because there's always a minus right there. And that's over e to the x. And then if I simply combine my like terms, I would prefer to write it in descending order as well. I got x squared. Those two combine to give me negative 3x. I have a plus 1 over e to the x. And that is the derivative of x minus x squared over e to the x. All right, so that is the product and the quotient rule. And there they are again. We will do some more examples in class. We will probably prove at least the product rule just to show you where it comes from. And that is all for now. Thank you very much.